Click the bell icon to get latest videos from Ekeeda.
Hello friends, so this is a unique problem based on inventory scheduling where we have the factories which manufacture the product and we have the warehouses where we are required to store the products, and we need to decide how much quantity should be manufactured or produced at which factory. Let's first read the problem and start. So this is my problem. Priyanshu Enterprises has 3 factories at locations A, B and C. So this is the place of origin or the place of supply, and they supply to 3 warehouses located at D, E and F. They are the place of demand. The monthly factory capacities are 10, 80 and 15. So A का demand है 10, B का demand 80 और C का demand है 15, whereas my monthly demand is 75, 20 and 50. So let's check whether this balance or not. I have got 10, 80 and 15, which comes to 105, whereas if I go by the demand, I have 75 plus 20 plus 50, which comes to 145. So I can say the problem is not balanced. Then we have a penalty cost for not satisfying the demands at the warehouses D, E and F at rupees 5, 3 and 2 per unit respectively. Using VAM, find the basic feasible solution. So that's our first part. Let's obtain the initial feasible solution by VAM method and then we can proceed further. Let's draw the diagram now. So here we have A, B and C. Here we have D, E and F. And our demand is more than the supply. So I need to add a dummy factory, let's say D1 or D0, which will add the additional capacity. Now the next big part in this problem is the penalty cost. Where should I use the penalty given for each of the warehouses 5, 3 and 2? Let's first try to balance the problem. So here is my demand. Our demand is 75, 20 and 50. 75, 20 and 50, which comes to 145. And our supply or the monthly capacities of the factory are 10, 80 and 15. So 10, 80 and 15 is my supply. So if you can observe, this is 105. So I have a demand, I have a supply of dummy supply of 40 units, and I write down a dummy here. And let's put down the cost now. We have the transportation cost or the shipping cost 563. So 563. Then we have 1, 4 and 2. 1, 4 and 2. And then we have 7, 6 and 5. 7, 6 and 5. Now friends, generally we always introduced a dummy in the row or the column with a cost of 0, because at dummy there won't be any allocation. Dummy is only an imaginary factory or an imaginary row and column which helps us to solve the problem. So technically the final solution will never contain the dummy, or else I should say dummy is not going to supply anything. So in case I make an allocation from dummy to D, there won't be any allocation. That means that much quantity of demand won't be satisfied in that particular warehouse. And they have clearly told us that there is a penalty cost for not satisfying the demand at the warehouse. Warehouse में डिमांड सेटिस्फाई नहीं करने के लिए आपको पेनल्टी लगेगा. सो अगर हम किसी भी डमी में एलोकेशन करते हैं, इसका मतलब उतना क्वांटिटी रियल लाइफ में प्रैक्टिकली हम सप्लाई नहीं करने वाले. इसलिए हमें ये जो पेनल्टी कॉस्ट है DEF का, वी हैव टू पुट इट हियर because that is the cost we are going to incur for not supplying or for supplying through the dummy unit. So with this, my question is done. The new part in this problem was the penalty cost involved for the dummy row or a dummy column. So now let's try to get the initial feasible solution by WAM. We have a row penalty here. We have a column penalty here. We will calculate the penalties first. In my first row, I have got a lowest cost of 1, and the next lowest is 5. The difference is 4. In my second row, I have got a lowest cost of 4. Next lowest is 6. The difference is 2. In my third row, my lowest cost is 2. And the next lowest cost is 3. The difference is 1. In my fourth dummy row, the lowest cost is 2. Next lowest is 3. Difference is 1. What we did row wise, we are going to do column wise. In my first column, my lowest cost is 3. Next lowest is 5. So the difference is 2. In my second column, the lowest cost is 1. Next lowest is 2. So the difference is 1. In my third column, I have got the lowest cost of 2. And the next lowest is 5. Difference is, so we can see the highest penalty among the rows and the columns is 4. At 4, my lowest cost is 1. So at 1, my supply is 10 and my demand is 20. I will supply whichever is less. So 10 minus 10, it shall become a 0. 20 minus 10, it shall become a 10. Now since I have got a 0, in the first row, I will simply cancel that particular row. Since a row has been cancelled, our row penalties will remain same, and we need to recalculate the column penalties. In the first column, I have got lowest cost of 3, next lowest is 5, difference is 2. In the second column, I have got the lowest cost of 2, next lowest is 3, difference is 1. In the third column, my lowest cost is 2 and the next lowest is 5, difference is 3. So we have got a highest penalty of 3 in the last column after the second stage. At this stage, the lowest cost in the last column is 2. Your supply is 40, your demand is 50. Whichever is less, you will supply 40. 40 minus 40 is 0. 50 minus 40 is 10. Since we got a 0 in the last column, I will cancel the last row. Now, since I cancel the row, my row penalties will remain same, and I will recalculate the column penalties. 6 and 3, 3, 4 and 2, 2, 6 and 5, 1. So you observe that my highest penalty at this stage is 3, and at 3 the lowest cost is 3, when my supply is 15 and my demand is 75. So 15 or 75, whichever is less is 15. 15 minus 15, it will be 0. 75 minus 15, it will be 60. Since I got a 0 in the third row, I'll cancel this row. Now after this cancellation, you can see I'm left with only one row, that is the B wala row. At this row, I will directly make the allocation of 60 ka demand at D. 60 minus 60 will be 0, 80 minus 60 will be 20. Since I got a 0 here, it shall be cancelled. Then the second demand at E10 will be satisfied directly here. There is no other option. It will become 0, 20 minus 10 will be 10. Since I got a 0 here, it shall be cancelled. And next, I am left with only 10 ka demand and 10 supply, which will be put down at BF. So 10 minus 10 is 0 and 10 minus 10 is 0. Since I got a 0, I will cancel it out. Since I got a 0, I will cancel it out. So this is the initial solution I have obtained by VAM method. Now in my next table, I am going to check the optimality of this solution. How to check the optimality? For that we have the Modi method. Let's redraw the table again without penalties. So we'll just note down the whole solution again without the penalties. To check the optimality, we are going for the Modi method. So this is my original table. We have A, B and C. We have a D, E and F. Here is my supply. Here is my dummy. And here is my demand. So I'll just note down the whole table again. 5, 6, 3, 5 and 75. We have 15 here and 60 here. 1, 4, 2, 3. Allocation of 10 and 10 here. Then we have 7, 6, 5 and 2. We have allocation of 10 and 40 here. And now I'll put the demand 75, 20, 50, which comes to 145, and my supply 10, 80, 15 and 40, 145. Now under Modi method, we introduce the parameters called as U and V to check the optimality of the solution. So let's put a U here and a V here. I'll put a 0 here. Conventionally we put a 0 in the first row. In the first row I have only one occupied cell, that is 1. At this cell cost is 1 minus U. Cost minus U will get you V. So 1 minus 0, it will be 1. So by using this 0 I obtain this 1. At this particular column, in this particular column, my other occupied cell is 4. So 4 minus 1, that is cost minus V. 4 minus 1 will give me U, which is 3. Then again in this second row there are two more occupied cells, 6 and 6. At this cell my cost is 6 minus 3, which comes to 3, and 6 minus 3, which comes to 3. Let's check whether we have obtained all the U and V values. There is still one more value left. At this particular row we have an occupied cell here. So my cost is 3. 3 minus 3 will be 0. So I have one more row where I have to find out the value of U. In this particular row I have got an occupied cell here. So 2 minus 3 minus 1. So we have got the u and the v values, and now we are supposed to calculate the delta values for unoccupied cells. So let's calculate the delta values for unoccupied cell. So my first unoccupied cell is AD, cost is 5 minus 0 plus 3. AD cost is 5 minus 0 plus 3, which comes to 2. My next unoccupied cell is AF, cost is 7 minus 0 plus 3. AF cost is 7 minus 0 plus 3. My next unoccupied cell is CE, cost is 2. 2 minus 0 plus 1. CE cost is 2 minus 0 plus 1, which is 1. Next is CF, cost is 5 minus 0 plus 3. CF cost is 5 minus 0 plus 3. Next we have dummy, where the cost is 5. 5 minus 1 plus 3. So at dummy D, cost is 5 minus 1 plus 3. At dummy E, cost is 3 minus 1 plus 1. At dummy E, cost is 3 minus 1 plus 1. So we'll calculate the delta values of unoccupied cells, and we get the answer as 2, 4, 1, 2, 2 and 3. I'll just note down these values in the table. So 2, 4, 1 and 2, 2, 3. So 2, 2 and 3. You can observe that delta values of unoccupied cells are positive. That means this table shall give me the optimal solution. So we have got all the delta values which are positive. So we'll write a conclusion. Since the delta values are not negative, the solution is optimal. Now what shall be my solution? We'll get the final solution in the next table or in the next page. Total transportation cost. We have to simply multiply the allocations with the cost. So 10 into 1. 60 into 6. 10 into 4, 10 into 6. 15 into 3. And last we have 40 into 2. So it is 10 plus 360 plus 40 plus 60 plus 45 plus 80, which shall be 410, 470, 350 and 395. So here I got the final answer. The question had asked us in the problem the optimum cost. We are supposed to find out the feasible solution and test for optimality. So we tested for the optimality and we got the final answer. So this is our final answer. The total cost of transportation will be 395. Thanks for watching our videos. Do subscribe to our channel Ekeeda.